Hello all. This problem is also similar to the last problem we saw, except that the value of s is changed here, right? So I think you'll all be in the flow to complete it. So let's do it. Okay. The open loop transfer function of a unity feedback control system is given g of s, and the value of gain is nothing but the value of k for which this point lies on the root locus. That means what is the value of s? They're given us with the value of s, and we are supposed to find the gain or the value of k for which this point s lies on the root locus. Okay, so let's do for this what we have, just like the last problem we solved. We have to find the closed loop transfer function from which we'll get the characteristic equation which we can equate to 0, and then we can find the value of k from this. Alright, while finding the value of k, we'll just plug in the value of s because this equation has s here, right? That's it. So the first thing we're going to find the closed loop transfer function that we know as g of s divided by 1 plus g of s into h of s. As this is a unity feedback system, h of s will be 1. Okay, I always mention that so we don't forget it. So let me substitute everything and plug in the values. We'll get the answer so soon. Okay, only one thing this would be is like we have a complex part as well, so it would take a little bit of time, a minute or two more than what we did in the last problem. Alright, let's do it. So 1 plus g of s k into s plus 4. We can always skip this step, okay, but I'm doing it so just for this video, but you can always skip this step and come to this step. S plus 4 divided by, this is going to get cancelled, so s plus 8 into s square minus 9 plus k into s plus 4. So this is our characteristic equation. The denominator of the closed loop transfer function is the characteristic equation. So now we can equate this to 0 and get the value of k. So when I equate to 0 and get the value of k, the k would be equal to minus s plus 8 into s square minus 9 whole divided by s plus 4. Now we have to plug in the value of s equal to minus 1 plus j2 everywhere. So if we plug in the value, we'll have minus out here, minus 1 plus 2j plus 8, 2 when you square this, 1 and then 4, get minus 4 and then minus 4j minus 4j minus 9. Okay, we got this much, divided by s plus, okay, we have to plug in again, the s is minus 1 plus 2j plus 4. Okay, so let us simplify this further. We have minus outside, so I'll keep it there, and then it is 7 plus 2j, 7 plus 2j into, this is minus 3 plus minus 9 is minus 12, so minus 12 minus 4j the whole divided by 2j plus 3. Alright, this is the value of k, before which we need to simplify this further and get it. So when you multiply, we're going to find the magnitude value for this only, so just we don't have to consider the minus anyway, it isn't going to matter. We're going to find the magnitude for this so that we can get the value of k. So root of real square plus imaginary square, real square is 7 7 is 49, 49 plus 4 into root of 12 square 144 plus 16 divided by root of 13. So when we just multiply everything, we get root of 8480 divided by root 13, so which happens to be 25.54. I'm just using the calculator for finding the calculations. You can also check it out. We got the value of k to be 25.54, and that happens to be the answer. Alright, so that's it. Thanks for watching, and please give your suggestions and comments on the comment section. Thanks for watching again.